Good morning. Today we're going to start lesson 9.8 and we're going to spend a couple days on this because I think that this lesson is something that's very important to be able to do. This is kind of one of the main reasons we do math in general. And so I really want to make sure that we have a good understanding of how to write and solve an equation. So that's what we're going to look at today. But first, let's do a little review in your bell ringer space. Evaluate each expression using the values r equals 3, s equals 4, and t equals -2. So anywhere we see an r, we put a 3. Anywhere we see an s, we put 4. And anywhere that we see t, we put -2. So in this first one, I'm going to substitute in the known values. The known value for s is 4, plus the value for t is -2. Well, when I combine those, I get 20 plus -2, and that would give us 18. So this would be the evaluated expression. For the second one, I'd have -3 times 3, and then minus 4. So that's going to give us -9 minus 4, and -9 minus 4 would give us -13. All right, so we're going to use some of these skills today, but first let's look at a word problem. So the first example says a 150-pound woman burns about 131 calories per mile running 6 miles per hour. She ran 40 miles this week and 35 miles last week. How many calories did she burn this week? And some of you may be able to go through this problem just kind of putting pieces together and eventually get to the right answer, but I don't want us to keep doing that method. I want us to actually learn how to write a good, concise equation. So the first thing that we need to do is to write a function rule. And to do that, we're going to start by determining what the problem is asking you to find. What are we being asked to find? We're being asked to find how many calories she burned each week using the speed and distance she ran. How many calories she burned each week using the speed and distance she ran. So now we're going to put our equation into words. And in words, it would look like this. The number of miles ran, you might use different colors, maybe that would help. And then we have an operator times the rate the calories are burned. And then we've got this word is, and I'll talk about that in a minute. And then the number of calories burned. So actually, let me change this up. Let me do some different colors. Should have been doing that as I went. So make sure that you write this equation out in words. This is going to be part of your homework. Number of miles ran times the rate of calories are burned is the number of calories burned. And then once we have it in words, we can write it as an equation or something that we've seen up till now. And we're going to write it like this. The number of miles ran, we use M for miles. So we've got, let me do that differently. Sorry, let me underline it. We've got miles. And then we have that operator times. Times is multiply. The rate that the calories are burned, it tells us in the problem that she burns 131 calories per mile. And then the number of calories, it's equal to the number of calories burned. So if you write it like this first part, I would accept that, but it's even better when we're doing multiplication to write it as the number and then the variable, just put them right next to each other. And that should look pretty familiar. I do want to point something out really quickly. There was some extra information in here. Did you see that? What do you think was the extra info? It looks like we didn't need to know that she was 150 pounds. That didn't really help us solve anything. We didn't need to know that she runs 6 miles an hour. That wasn't helpful. And eventually, we may need to know that she ran 40 miles this week and 35 miles last week if we're asked to solve it. But we're first writing an equation, and so we don't need those just yet. If we were to take those, though, and say she ran 40 miles this week, we would take 131 times 40 equals C. And then we would need to multiply those together. When we multiply them together, give me just a sec, we get sorry about that, 5,240. So in 1 week she earned 5,000 or burned 5,240 calories. Then last week it says she ran 35 miles, which sounds absolutely horrible to me. Maybe some of you think that sounds awesome. But we've got 131 times 35, and we get 4,585. So here, this is how much she earned this week, and this is how much she earned last week. So if I wrote this as a sentence, I would say she burned 5,240 calories this week, and 4,585 last week. And there we have it. So let's look at another example. Stacy and her dad are in charge of ordering t-shirts for the Father's Day 5K fun run. I don't know what's with all these people and running. Anyway, they order a large number of t-shirts from a website that allows Stacy to upload her own design. When the shirts arrive, Stacy discovers that 25 of the shirts have the wrong design. Now Stacy and her dad only have 225 usable t-shirts. How many t-shirts did they order? So start by saying, what is the problem asking? The problem is asking, how many usable shirts did they have after the 25 with the wrong design? So write the equation in words. We're going to say that we take the total number of t-shirts and we have to minus or subtract the unusable shirts is the number of usable shirts. All right, so we've got those parts there. We've got total number of t-shirts. We're going to call that T because we don't know how many. We don't know how many. That's what we're being asked to find. T, and then minus. How many unusable shirts were there? There were 25 that were the wrong design. So minus 25 equals the number of usable shirts. And they tell us that they had 225 usable shirts. So here's our equation. This is part of the process. Some of you may be able to look at this and do some logical thinking, but again, we're practicing writing the equation, so you have to put the equation in symbols. Excuse me. So now to solve it, we're going to add 25 to both sides, and we would get T equals 250. So we would say they ordered 250 t-shirts. All right, one more. Try this one and then pause the video while you are trying it and then come back and we'll check your answer. All right. Family membership at a science museum costs $89 per year. In addition, Omnitheater shows cost $22.50 per family each visit. How many Omnitheater shows could a family see if its yearly budget is $300? So what is the problem asking? They're asking something along the lines of, and your wording might look a little bit differently, how many shows can a family see when they have a membership. That's what I would say. All right, so now we need to put the equation into words. So the equation in words would be the cost of membership plus, because it does say in addition, plus cost of each show. Let me redo that. And then it's going to be plus the cost of each show times the number of shows, because it's not just plus the cost, the $22.50, it's each visit. This each visit means that we have to times it by the number of visits times the number of visits is the yearly budget. All right, so that's a lot. That's more than the last one, but we're going to work through this bit by bit. So cost of membership. The cost of the membership is $89. And then it says, in addition, it's the cost of each show. The cost of each show is $22.50 times the number of visits. But the it says how many Omnitheater shows could they go to? We don't know how many shows they go to. So we're going to say, I don't like using S as a variable because it looks too much like a 5. So I'm just going to go ahead and use X. And X is going to be the number of visits, or the number of shows. And then equals, change it up again, let's go with this color, the yearly budget. And their yearly budget is $300. So now we have a two-step equation. Before it's just a one-step, now it's a two-step. So our first step is to subtract 89 to both sides. When we do that, we get 2250 x equals 211. And then we need to divide both sides by 2250. And we get x equals 9.31, oh no, 378. And it keeps repeating. Now, does this mean that they could go to 9.378 shows? That doesn't really make sense. Because we can't go to 0.378 of a show. That'd be like walking in for the first 3/8 of the movie or so, and then being like, oh wait, we're out of money, time to go. No one's going to do that. So, without going over their budget, the most number of shows the family can see is 9. And that's it. All right. So, for your homework, you have 3 problems to do. And this is going to be posted in Google Classroom, but this is very important. You must show all steps, just like we did in the notes. So you're going to do this in a Google Doc, or if you want to do this on paper and then take a picture and upload it, you can. I would prefer it in a Google Doc because there's some typing that goes on. And I think that this can be done pretty easily in Google Docs, but I have to see what is the problem asking. I need to see write the equation in words, write the equation in symbols, solve it, and then write a sentence. So there's only 3 problems, but there's 5 different steps that need to go with each one. Make sure you're making it very clear what each problem is asking. All right, let me know if you have questions, guys. Bye.